Hey there, class. Mr. Foskey here. Hope you're having a good day so far. We are continuing with Chapter 7. Chapter 7 is going to be working with right triangles, Pythagorean theorem, trig ratio, stuff like that. And an important skill we need to kind of refresh ourselves on for that is going to be simplifying radicals. So radicals are square roots, cube roots, that kind of thing. And so we're going to do that today, and then the rest of the chapter is going to be introducing you to some important topics for trigonometry and stuff, and Pythagorean theorem, which is very useful. Okay, so why don't you guys go ahead and do the warm-up here? It says, which of the following radicals are perfect? It says, which come out to a single whole number. So why don't you guys pause the video and see how you do. All right, number one, what do you think? Is square root of 18 a perfect square? Well, hopefully for this chapter that I gave you like a perfect square card. So what are some perfect squares? Well, perfect squares are when you take the square root, like square root of 1 equals 1, right? So what's the next perfect square? Square root of 4, right? Square root of 4 equals 2. So these are numbers that are just like a whole set of numbers that when you take the square root of them, they come out to a nice whole number. So what do you guys think? Is 18 on there? It is not, right? So it'd be 16, it'd be square root of 16, square root of 25. So this one is going to be a non-perfect, okay? All right. Well, I gave one away here. What do you think about number 2? Is square root of 16 a perfect square? It is. It is going to be a perfect because square root of 16 equals 4, which is a nice number. What if you take the square root of 18? What's that going to be? Well, any number besides perfects is going to come out to like a non-terminating, non-repeating decimal, which is going to be like, it's going to go on forever, it's not going to repeat, and it's just kind of a nasty number. So yeah, anything that's not one of these numbers we talked about, 1, 4, 9, 16, 25, 36, stuff like that, it's going to be a non-perfect. How about number 3, square root of 64? That is a perfect, because the square root of 64 is what? It is 8. Very cool. All right, so let's talk about a couple rules with working with radicals, or in this case, square roots, okay? So like when we simplify fractions, so for example, if we have let's say 6 over 8, right? If we want to reduce that, we want to find the biggest factor that goes into it, right? So 2 goes into 6 how many times? 3 times. 2 goes into 8 how many times? 4 times. So we get 3/4. So 6/8 is the equivalent of 3/4, okay? So when we're working with radicals, we can do something called the product rule, which means if we have 2 numbers being multiplied under a radical, it's the same thing as if you split up those numbers with radical and kind of put radicals over them. So basically you can take any number and split it into smaller numbers and smaller square roots, or you can take 2 smaller square roots and you can combine them. So what we want to do though, I mean, we don't want to just do anything. We want to find like the biggest perfect square that goes into the number, right? So for example, for number 1, we have square root of 27, right? So what multiplies to 27? Well, we got 1 times 27, and we have 3 times 9, right? Are any of those numbers perfect squares? Yeah, 9 is. So like on your calculator, you would kind of like divide. You would divide, 27 divided by 25, right? But you start with the perfect squares and you divide down until you get numbers that work. Then 16, then 9, then 4, then 1. So we want to find the biggest perfect square that goes into 27. In this case would be 9. So we can write this square root of 27 as square root of 9 times 3, right? We're not changing it, right? Because a 9 times 3 is still 27. And then what we can do, which is kind of nice, is we can split it up. And we can write square root of 9 times square root of 3, right? And then what is the square root of 9 going to be? It's going to be 3. And we can't really do anything with the square root of 3 because it's like less than the next perfect square, which would be 4. So the simplified version of this, kind of like simplifying fractions, would be 3 square root of 3. And if you were to do square root of 27 on your calculator and 3 square root of 3 on your calculator, they're basically going to be the same thing. Okay? Why don't you guys go ahead and pause the video and see if you can do 2 through, there's actually 2 number 3s here. I apologize for that. Try 2, 3, and 3 and see if it makes sense to combine them or split them up. Give it a try. All right, let's see what happened here. All right, so number 2, we have square root of 25 times 36. We could multiply these, right, if we wanted to, but that's going to be kind of a really big number. What do you notice about both these numbers under the radical here? Well, they're both perfect squares, right? So I would probably split these up. So I would write square root of 25 and square root of 36. And what's the square root of 25? It is 5. And what's the square root of 36? It is 6. And what's 5 times 6? It is 30. Now let's do the same problem a different way, right? Let's say we do combine them. There's nothing wrong with that. That's a valid thing. 25 times 36 is going to be a square root of 900. And what is the square root of 900 going to be? That is also 30, right? So there's two ways you could do this one. I personally don't like to make numbers bigger. I like to make them smaller, but either way is totally valid, okay? How about number 3 here, the first number 3? What is the biggest perfect square that goes into 50? It is 25, so you should have gotten square root of 25, and 25 times what is 50? Times 2. And so we can go ahead and simplify this. What's the square root of 25? It is 5, and square root of 2 we can't do anything with, so we get 5 square root of 2. All right, how about the second number 3? So should we split this up or combine it? What do you think? Well, we could split it up and do square root of 3 times square root of 12, but what is 3 times 12? Well, 3 times 12 is 36, so I can do square root of 36. And what kind of number is that? It's a perfect square, right? What's the square root of 36? It is just 6. Okay, so nothing wrong with splitting it up here, but I would always say, does it make sense to multiply it or divide it and kind of go from there? All right, moving on. New color, new problems here. Quotient rule. So product rule is like you can split up things being multiplied. Quotient rule is very similar. If you have like a fraction under a radical, you can split it up into separate radicals, okay? So you want to ask yourself, does it make sense to divide it or does it make sense to just split it up? Well, let's take a look here. So we have square root of 18 over 16. What do you guys think? Does 18 divide by 16 nicely or not really? It does not. So I'm going to go ahead and I'm going to split it up and put square root of 18 on top over square root of 16. Okay. All right. Is 18 a perfect square? It is not. So we can split this up. What's a perfect square that goes into 18? Well, we know that 1 times, 18 is 18, 3 times 6 is 18. Those are not perfect squares. But 9, square root of 9 times square root of 2, 9 is a perfect square, so that works. And what's the square root of 16 on the bottom? That's going to be 4. All right. And then if we simplify, the square root of 9 is going to be what? We got 3 square root of 2 over 4. And you always want to ask yourself, does it make sense? Can you divide? We can't really divide the square root of 2 and 4 because it's got a square root. But the 3 and the 4, can we do anything with that or not really? We cannot. 3/4 is not going to really simplify. So we're good. All right, I'm going to zoom out here. Why don't you guys go ahead and try 2 through 4 and see how you do. All right, number 2. This one, we have square root of 12 over 4. I'm going to blow your mind here. If you like split it up here, you probably did a lot of extra work that you didn't need to, and that's okay. But let's take a look at this here. So what we want to ask ourselves is 12 divided by 4 nicely? It does. What's 12 divided by 4? It is 3. So I can literally just do square root of 3 and I'm done. Okay. If you split it up, you probably got the same answer if you did it right. But always ask if it makes sense to divide first. Okay. How about number 3? Square root of 25 over 36. Again, these are what kind of numbers? Well, first, does 25 divide by 36 or no? It does not. So we can go ahead, we can split this up because, yeah, you'll see why. So we got square root of 25, square root of 36. I did not write that well. And what is square root of 25? It is 5. Square root of 36 is 6. Does 5 divide by 6 nicely or no? It does not. So we get 5, 6 is our answer. All right, number 4, square root of 48 over 20. Does 48 divide by 20 or not really? It does not. So we're going to split it up. So we got square root of 48 on top over square root of 20 on the bottom. Okay. Let's see here. Yeah, so we can't really do anything with this. These are not perfect squares. So we got to pull out the biggest perfect square that goes into 48 and 20. So what number goes into 48? That's a perfect square. It's going to be 16 times 3. So we got square root of 16, square root of 3. And on the bottom, square root of 20, we can pull out a square root of 4. 4 is perfect square. Times square root of 5. All right, we can simplify this a little bit. What's the square root of 16? It is 4. So we got 4 square root of 3. Square root of 4 is what? It's 2. So we got 2 square root of 5. Now, can we do any reducing or simplifying here? Well, the 3 and 5 are under square roots, so we can't do anything with that. But how about the 2 and 4? It's like reducing a fraction, right? What number goes into 2 and 4? 2. Does 2 go into 2 how many times? Once. 2 goes into 4 how many times? Twice. So now we get 2 square root of 3 over square root of 5. And that's going to be our answer. You'll actually see in the next section we don't really like this answer. There's something wrong with it. But for now, we're just going to leave it like that, okay? All right, last section, then we'll call it a day for this lesson here, okay? So what I was just talking about, the thing we're going to talk about next is called rationalizing the denominator, okay? With radicals, we do not like radicals, just kind of like we don't like negatives in the denominator of a fraction. We kind of float it to the top. Same thing here, we don't like radicals in the denominator. So that's kind of what's wrong with this one over here. We have square root of 5 over here, right? So we're going to go ahead and we're going to show you how to fix this, okay? So mathematicians have this kind of trick that's kind of cool. So for example, if I have like 4x and I add 2 and I subtract 2, what's plus 2 minus 2 going to be? It's going to be 0, right? It's basically like 4x plus 0, okay? We also, what if we did like 7 times 8 over 8? What's 8 divided by 8? That's 7 times 1, right? So we have this trick that, even though it's kind of weird, if we multiply by 1 or we add 0, variations of that, it's going to help us kind of simplify things here, okay? So what we're going to do, we have 10 over square root of 5 for our first example. What radicals in the denominator here? We have square root of 5. So the way we're going to fix this is we're going to multiply top and bottom by square root of 5. We're going to multiply by 1 because square root of 5 divided by square root of 5 is going to be 1 basically. So we're not really mathematically changing it. We're just kind of manipulating it a little bit. Okay? And then 10 doesn't multiply square root of 5, so we're going to get 10 square root of 5. What happens on the bottom though? Let's kind of visit this a little bit. What if I did square root of 2 times square root of 2? That's going to be square root of what? Square root of 4, which equals what? It equals 2, right? How about square root of 9 times square root of 9? That's square root of 81, right? 9 times 9 is 81. And what's square root of 81? It's 9, right? So you see the pattern here? If we multiply the same square root times itself, what do we get? We get the number under the radical. So what's square root of 5 times square root of 5 going to be? That's going to be square root of 25, or just what? Just 5. Okay? All right, we done? We're close. We got to do one little thing here. Can we do any reducing of the fraction? We can. We have 10 and 5. What number goes into 10 and 5 nicely? 5. 5 goes into 5 how many times? Once. 5 goes into 10 how many times? Twice. So now our final answer is going to be 2 square root of 5. Okay, that's the example for that. We have 2 left to do. Why don't you guys go ahead and pause the video and see how you do on those? All right, we have 3 over square root of 2. How do we get rid of this radical in the denominator? We're going to multiply top and bottom by square root of 2. So on top, we get 3 square root of 2 over, what's square root of 2 times square root of 2? That's going to be just 2. Can we do any reducing here? 3 doesn't divide by 2 nicely, so we're going to just keep it as 3 square root of 2 over 2. All right, last one, 8 over square root of 6. Let's see here. We're going to multiply by square root of 6 on top and bottom. So for this one, we get 8 square root of 6 on top, and we get just 6 on the bottom, square root of 36. Can we do any reducing here? We can. What number goes into 8 and 6 nicely? 2. 2 goes into 6 how many times? 3 times. 2 goes into 8 how many times? 4 times. Now we get for our answer 4 square root of 6 all over 3. All right, and that is our answer. Okay, that should be all I have for you today. Thank you for watching. Have a great day, and we will talk soon.